This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part of a series of videos where we're going to be solving more complicated trigonometric equations where we might need to use these methods: factoring, the quadratic formula, or other methods for solving quadratics. We might have to use trig identities. We might have to square both sides. We also might be dealing with multiple angles. Keep in mind that anytime you square both sides of an equation, it's essential that you check solutions for extraneous roots. We're going to solve this trig function, 2 sine squared x plus cosine of x equals 1. So one thing I might do is subtract 1 from both sides and then see what I've got. 2 sine squared x plus cosine of x minus 1 equals 0. And this looks a little bit like a quadratic, but it really isn't, because I have a cosine x, and over here I've got a sine squared x. I don't have the same trig function. So is there some identity I can use so that I have everything in terms of either cosine or sine? And the sine squared x can be written in terms of the cosine. So in other words, sine squared x could be written as 1 minus cosine squared x, and now this means I'm going to have an equation with just one of the trig functions, just the cosine. You could have done that in the first step too, changed your sine squared x to 1 minus cosine squared x. All right, so let's just simplify this a little. On the left-hand side, we have 2 minus 2 cosine squared x plus cosine of x minus 1 equals 0. So let's see, I've got a negative 2 cosine squared x, a plus cosine of x, and this 2 minus 1, that adds up to 1. And now when I analyze it, I have a quadratic. This is similar to negative 2y squared plus y plus 1 equals 0, except instead of a y, I have a cosine of x. Now personally, I like having positive in front of the squared term. So you could either put everything on the right-hand side of the equation, putting 0 on the left, or you could multiply both sides by negative 1, which changes all the signs. So I'm going to do that. Let's just divide everything by negative 1. That's the same thing as multiplying by negative 1. So in other words, I've got 2 cosine squared x minus cosine of x minus 1 equals 0. Now, if it's easier for you to replace cosine of x with another variable like m or y before you factor, that's fine. I'm hoping we're okay just going right to it here. So I know for my coefficients I'm going to have a 2 and a 1, but to get cosine squared I need one cosine of x in both places, right? So I've got 2 cosine of x in here and another one in the beginning of that parentheses. That'll give me my first term of 2 cosine squared x. The only way to get a minus 1 is this will have to be 1 and 1. I just have to decide where to put the plus and where to put the minus sign, and this gives me my right middle term. So sometimes it doesn't factor. In that case, you'll have to use the quadratic formula. We'll do that in another video, but this was nice. It factored. Wasn't too hard. The numbers weren't too difficult. And I don't know why I wrote equals 2. That was equal to 0. So now we set each factor equal to 0. Sorry. And then solve for each. So I have cosine of x. Can you do this all at once? Subtract 1 and divide by 2. That gives you the cosine of x equals negative 1/2. And this one, cosine of x minus 1 equals 0. If you solve for cosine of x, we get cosine of x equals 1. Now, the original problem said to find the solutions between 0 and 2 pi. So that's the next thing. Where is the cosine negative? It's in quadrants 3 and 4. So either you've memorized this or you have some other way of doing it. I always draw the triangles here. I don't memorize too much. And so this would be 2 pi over 3. That's one of the solutions for this one. And this would be 3 pi over 3, 4 pi over 3. That would be the other one. And if you think in terms of degrees, that's fine. Just make sure that you change it to radians. Okay, and I know that's 1/2 because of right here, right? That's that 30, 60, 90 triangle if you look at the sides of the triangle. There's the negative. Okay, now where's the cosine 1? Okay, that is one of the points on the unit circle, and that would be right over here at 1, 0. That's where the x-coordinate is 0. So that in radians is 0. Remember, we don't also include 2 pi because that's just coterminal. So I've got 3 solutions. 0, 2 pi over 3, and 4 pi over 3. And of course, it's always a good idea to check each solution in the original equation. Now, I've been doing this algebraically, but even if you plugged it in a calculator, put it in radian mode, take your original equation and plug in one at a time, at least you could see whether the left and the right-hand side were the same number once you simplified. So let's just check one of these algebraically. How about we do the 4 pi over 3? All right, so we're going to check x equals 4 pi over 3 in the original equation. And notice I'm putting in 4 pi over 3 for x. And so we're going to have to compute the sine of 4 pi over 3 and the cosine, right? So let's see, that's here, right? -1, negative root 3, 2. So the sine is negative root 3 over 2. So this is negative square roots of 3 over 2. And then we're going to square it. And the cosine is negative 1/2. All right, so on the left, I'm just going to do my order of operation. I'm going to square what's in parentheses. So that's going to give me a positive, right, because I'm squaring it. And square root of 3 times square root of 3 is 3. And 2 squared is 4. So this is 2 times 3/4 plus negative 1/2. I'm going to cancel. So I have 3/2 minus 1/2, right? Or 3/2 plus negative 1/2. And that's going to be what? 3/2 minus 1/2 is 2/2, which is 1. And the other side is 1. So this did check. So our original, we know that 4 pi over 3, for instance, is a solution. You could do the same thing for 0, plug in 0, and also plug in 2 pi over 3. You should get that the left and right-hand side are also the same number after plugging them in. And so therefore, our solutions are 0, by the way, just as a reminder, 0, 2 pi over 3, and 4 pi over 3. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.